This video reviews how to solve equations using square roots. This is section 5.3 and 5.4 in our book. So we are going to get answers that are both real, meaning there is no I value, and we're going to get answers that are imaginary. So it's the kind of the combination of the two. I'm going to go through 4 types of problems. Whenever you are solving these equations, there's really 2 things that could be happening. Either you have just an x squared, like the first one that you're looking at right now, or you have an entire quantity squared, like the second one you're looking at, where you have the piece in parentheses. Either way, whichever one you're looking at, you need to isolate what's being squared. So you need to get the x squared or the parentheses squared by itself. So as we start number 1, first step to get the x squared by itself is to add 4. So we have 3x squared equals 24. Next step in isolating it is divide by 3. So we have x squared equals 8. Once you've isolated the piece that's being squared, now you're ready to take the square root of both sides. A couple things to keep in mind. When you take the square root of both sides in an equation, you actually create 2 answers. You create a positive answer and a negative answer. So right away, I would recommend writing a plus minus. That is showing that you get a positive and a negative answer. The other thing that you want to think about is you need to look at the number under the radical and decide, is it a perfect square? Is it a number that has a perfect square factor? So those list of perfect squares will be helpful again, or is it a number that I can't have anything done to it? So when you look at the 8, we have 8 can be broken down into 4 times 2. 4 is a perfect square factor. So remember, the process is take the square root of the perfect one. The square root of 4 is 2. Leave the one that is not perfect underneath. This is your final answer. It is plus or minus 2 radical 2. If you want to check your work, you could take either of those values, plug it in where you see an x into the original equation, and you would get a true statement. The second one is a little bit different in that instead of having just an x squared, now you have a quantity that contains x squared. You still have to isolate. So we're still going to get rid of the 3 by subtracting it. So we have 5 times x minus 3 squared equals 60. Get rid of the 5 by dividing by it. So divide both sides by 5. We get x minus 3 squared equals 12. Again, we got to the point where we have isolated what's being squared, so now is the time when we take the square root of both sides. When you take the square root of both sides, you get a plus and a minus answer, so I'm going to immediately write that down before I forget. You need to look at the piece under the radical and decide, is it perfect? Does it have a perfect factor, or is there nothing I can do with it? This one is not perfect, but it does have a perfect square factor of 4 times 3. So you take the square root of 4. The square root of 4 is 2. You leave the 3 under the square root. Here's the difference with this one compared to the one we just did. At this point, you're not done. You're really close, but you're not done. If you look on the side, what you have is you have the square root of x minus 3 squared. You end up with x minus 3. X isn't by itself. That's the goal. In the end, we have to know what x equals. So I have one very short step left to take. I need to move the minus 3. So I'm going to add 3 to both sides. So x equals plus or minus 2 radical 3 plus 3. And I can't add those together because the first one has a radical and the second one doesn't, so they are not like pieces that can add together. My answer looks longer, but it is correct. I want to do 2 more, and the difference with these, it's still going to go through those same different types, but now we're going to get some answers where we have negatives under the radical. So we're going to review how do we deal with negatives under a radical. So when we look at this first one, again, it's kind of like the one we just did as far as we don't have an x squared, we have a quantity squared. We need to isolate that parentheses. So the first thing we're going to do is subtract 5 from both sides. So we get 2/3 times x minus 1 squared equals negative 32. Now we need to get rid of the 2/3, so we're going to multiply both sides by the reciprocal. We're going to multiply by 3 over 2. So we have x minus 1 squared equals, and here's where you can use a calculator, negative 32 times 3 divided by 2. You can do it in your head if you want. You end up getting negative 48. We have isolated the square piece, so now I'm ready to take the square root of both sides. Square root here and square root here. Immediately I'm going to write down the plus minus so I don't forget. I want to look at the number under the radical. It is not a perfect square. What is special about it, though, it is negative. So I am going to have an I with my answer. That's the way we adjust for having a negative under the radical. We write that small I. That's called the imaginary unit. 48 is not a perfect square, but it does have a perfect square factor of 16. It is 16 times 3. When I take the square root of 16, I get 4. So I'm going to put a 4. I'm also going to put an I. That's showing that there was a negative under the radical. And then I'm going to have the square root of 3. That's what x minus 1 equals. Notice I'm not done. I'm close. I have to get x by itself, so I'm going to add 1 to both sides. So my final answer is plus or minus 4I radical 3 plus 1. Again, I cannot add those together. One has a radical, one doesn't. One's imaginary, one's not. So we're going to leave our answer like that. I have one more I'm going to go over, and then I will have covered every type of combination that you could see when it comes to solving. This one's more like the first one we did. We just have an x squared, so we need to isolate that x squared. First thing I'm going to do is get rid of the 7 by subtracting it to both sides. So I get negative 5x squared equals 20. Then I'm going to divide by negative 5 to get the x squared by itself. So I get x squared equals negative 4. I have isolated the piece that's squared, so I'm going to take the square root of both sides. I get x equals plus or minus. 4 is a perfect square, so I do not have to break down a factor tree. The square root of 4 is 2. The one thing I do have to realize, though, is it has a negative with it. So instead of just getting an answer of 2, I get an answer of 2i. So my answer is x equals plus or minus 2i. So that gives you 2 where you had imaginary type answers. It gives you 2 of them had a parentheses p squared, 2 of them had just x squared. So you get to see all the different types that you'll be asked to do on a test or a quiz.